Hello everyone and welcome back. It's Jason again. We're going to watch the rest of Steven's video here, so if you haven't seen part 1 yet, click on the link in the description or go back in the Udemy course. So in part 1, Steven showed us some green screen technology and he talked about viral messages and medium versus message. In this video, we'll talk about how medium changes the message, and then we'll play around with some green screen tech, and I have a coding activity for you as well. So let's go ahead and switch scenes here, and let's continue.
Let's try just embedding her own message inside her message.
And though self-isolating may at times be hard.
So as a reminder, when we left off in part 1, Steven tried putting a video clip of I think monkeys sharing things in front of this, and we all agreed that it was a little distracting and they were kind of too cute, and it was actually taking away from the message. So now Steven is trying something that would support or add to the message. So we're trying, I guess this would be a meta message because it's her message inside of a message.
Many people of all faiths and of none are discovering that it presents an opportunity to slow down, pause and reflect in prayer or meditation.
Honestly, I like that better than the monkeys. I was more focused, less distracted. If we could do it twice, we could do it 3 times.
It reminds me of the very first broadcast I made in 1940, helped by my sister.
So I think what makes it a little better is that there's not there aren't added sounds going on. It's just a visual effect. It is catchy, it is entertaining, it's kind of funny, but I can still hear the Queen's message.
As children spoke from here at Windsor to children who had been evacuated from their homes and sent away for their own safety. Today...
Whoa. That image of the Queen with a younger self and her sister making her first historic speech, that's the first one I feel like genuinely may have boosted the message. By the way, that first speech itself was both medium and message, as this short clip from the Smithsonian Channel can attest.
The speech was written to offer comfort to homesick young evacuees sent overseas. But there was another, more important motive. Britain was desperate for an ally, and Churchill believed that the young Elizabeth could charm America into declaring war on the Nazis.
Once again, many will feel a painful sense of separation from their loved ones. But now as then, we know deep down that it is the right thing to do.
That was pretty good. Let's switch back to video.
While we have faced challenges before, this one is different.
Oh!
This time we join with all nations across the globe in a common endeavor, using the great advances of science and our instinctive compassion to heal.
Maybe a meme?
We will succeed.
Success.
And that's...
So when they were images, they were much less distracting. Now Steven's gone back to video, but he's chosen very specific video memes to at least support the messages and not change the message.
Success will belong to every one of us.
And now, as we have come to the end of the speech...
We should take comfort.
Wait. In the original color as well.
That while we may have more still to endure, better days will return. We will be with our friends again. We will be with our families again. We will meet again. Better days will return.
Great message. I can't wait till we can see our friends again. And yeah, it's good to be positive. Better days will return. So Steven mentioned his shirt was inside out the whole time. I don't know if he did that on purpose or not. But I mentioned in the first video, he is wearing a green shirt. So if you want to turn him into a video meme and do the green screen effect on his shirt, you can do that as well. Anyhow, what we're going to do next is show some of this green screen technology. We'll talk about how it works, and let's do a coding demo to see if we can code a basic green removal program. So right now I actually have 2 cameras set up right now, and one of them is a Kinect sensor. So here's my Kinect. It's a Microsoft Kinect. It's used to play games that have infrared tracking and things like that. So I don't have a real green screen, but I can use this Kinect camera to make what's called a virtual green screen. And this is some code that someone else already wrote to do this background removal or to replace it with green. And it's using Microsoft's skeletal tracking. So if I think I get too close, it'll stop tracking me. And then if it recognizes a person again, it will track where I am, and I can move, and it's always removing the background. So here it is. There's the background. There it is, removed. So now I have a virtual green screen. It's not the best, but if I had a real green screen, you'd have much smoother edges around my shoulders and things like that. Let's go ahead and actually work with this. So I'm going to shrink this down to, let's see, maybe 500 by 500. And let's go ahead and close Steven's video. So now I have this in the corner, and I'm using OBS to record my screen and to do these overlays and things like that. Now, what's neat about OBS, open broadcasting software, it also has some green screen filters. So it has a what's called a color key and a chroma key. So let me go ahead and capture this window here. There it is. So now I have that window captured. I can even take it and move it around. Let's go ahead and hide the one on the desktop so it's not as confusing. So now I have this Kinect camera that's been cropped and doing a green screen effect. Now that I have this solid green screen, I can add a filter to it, and I'll turn on what's called a chroma key, and it's already set to green. So now it actually removed that green background. I can put this in the corner over here, or I can cover my other picture-in-picture, and I can even resize it and things like that. So there's my green screen removal using OBS, using a virtual green screen, and that's basically how it works. You know, you need some kind of solid color that's somewhat uncommon, and then you can use software to remove it. So with that said, let me go ahead and get rid of that, and let's actually try and code something like this. So I have WeScheme open. It's a code editor. It's a lot like Dr. Racket, which is what I primarily code with. It is based on Lisp. What's nice, it has a bunch of image libraries already built in. I can pull up images. So let me go ahead and pull up an image of the queen here. And this is the older image where she's wearing like a bright green suit. In fact, there's some memes already, tons of memes already out there where they changed the suit to a pizza texture. So we're going to recreate that with code here. I've already grabbed a URL. And I've already cropped it, and I've already scaled it down. Now, I scaled it down just so that it's going to be easier to work with. So I ran that. Let me type base image. So this is the image we're working with. We don't want it too big because we're going to do pixel manipulation here, and we don't want to go through too many pixels. So this is scaled down by 0.5, and it's cropped to 400 by 400. So this is actually 200 by 200, right? And that means it is 40,000 pixels total. And that's a lot to go through. I think this editor can handle it. If not, we can actually shrink it down some more. So we have this, and what we need to do is remove the green from the image. And so what I'm going to do first is define what I want. I want to be able to, let's see, let me go ahead. I want to be able to run a function called remove green pixels from the base image. Now, that's not something that exists yet. So I'm going to go ahead and define it right here. So define remove green pixels from an image. So that's a parameter I'm calling image, and I'm going to use it and pass something in. Now, I can actually just return an empty list, or I can return a string that says modified image, just so I can run this without having errors. Now, that's where my modified image is going to be with the removed pixels, but we're going to take small steps at a time. The first thing I need to do is break down this image into its array of pixels. There's a function called image to color-list, and then you just pass in the image. Now, this is going to grab a giant list. I know, actually, I'm going to shrink this down even more. Now it's going to be a 100 by 100 image. And I'm going to run this. Give it a second. And there we go. Now I've broken down the image into its array of, or its list of color structs. So these are colors. A color has a red value, a green value, a blue value, and then an alpha value. Alpha means transparency. So 255 is fully opaque and 0 would be completely transparent. So R, G, B, and A. Now what I want to do is go through and filter all these, and if it's green, I want to make them transparent. I don't even care what the color values are. I can just make it color 0000 and it will be transparent. And once it's transparent, we can just overlay it on top of any image and we'll see that image underneath. We have R, G, and B. Let me go ahead and pull up a photo editor here. This is paint.net, and I have some color picking tools. And the idea is I don't want to just remove a specific green color. I want to remove a kind of a range of green colors. And we can see the R, G, and B values kind of go up and down right there. But even better is if we actually did this to the original image. So let's go ahead and type in base image. Whoops, I'll just capture the screen and paste it into Paint. Keep canvas size, and I will just rotate until we have that. Zoom in. So we just want to use the eyedropper tool or the color picker, and we want to just inspect these colors. So we have green values that go all the way up to like 240, but they go as low as, so I'm looking at green here, they go as low as 238, 235. It's also important to know that if I looked at white, white also has high values in all three of them. So I can't just say, hey, green values of greater than 200, because then I'll also remove white and any bright colors along the way. And by the way, black is the opposite. It's all low colors, like 000 is pure black. So let's look at these other values. So we have green that's greater than 200. We also have red that's usually less than about 190. And we have blue that's always kind of less than 180. Let's use 200 kind of as our threshold level and see how that works out. So we want to remove anything that has a red value that's less than 200, a blue value that's less than 200, and a green value that's greater than 200. So what we're going to do is we have this image list. We want to map some function to it. That means for every single one of these colors, we want to apply something that either keeps the color or changes it so it's transparent. And so I'm going to call that function remove green pixel. So this function is called remove green pixels with an S. I'm going to make one that's remove green pixel that applies to just one of these pixels, and I want to map it to the entire list. Now that doesn't exist yet, so I have to write that first, otherwise I'm going to get an error. So define remove green pixel, and this one takes in just a color, right? And it needs to go through that color and do a couple of checks. So I'm going to write if, and let's do it in the order of R, G, and B. So I'm going to say if the, I'm going to use a less than comparison, and I'm going to grab color red color. So if the color, if the red value of the color is less than 200, and let's see, and I want to combine these in an and, so I'm going to write and there. So if the red value is less than 200, I'm going to copy paste this 3 times because we have 3 values. So we have red, we have green, and we have blue. Now, if red is less than 200 and green is greater than 200 and blue is less than 200, and I'll go ahead and end the and. If all those are true, that means we found something that fits in our threshold, fits in our green range, and we want to just make a color, a new color. So instead of using the color that we passed in, we're going to return a new color that's just going to be 0000. Now, the important bit is 0. That means it's going to be transparent, right? And if it doesn't fit in that range, because this is an if statement, we have if condition, do this, else do this, or return this, else return this. So what we want to return, if it doesn't fit in that threshold, is we want to preserve the original color. So we'll just return the color that was passed in. Same thing as kind of do nothing, right? Now, if I run this, this is already mapping that function onto the image list. So what this should do is give us a new image list. Whoops, I'm missing end parentheses. This should give us a new image list that should have some 000s in there. So let's go ahead and scroll through really quick. Oh, great. So there's a bunch of ones that fit our threshold, and it made them transparent, right? But this is not an image. This is a list of colored structs, a list of pixels. We want to turn those back into an image. So there is a function called color list to bitmap. So I'll run color list back to bitmap. Because remember, we took the image, turned it into a color list. Now we got to turn it back into an image. So it's called color list to bitmap, and we can't just run it. It needs two more. It needs two more parameters. So it takes in a list of colors, but then it also needs the width and the height. Otherwise, it doesn't know how to reconstruct this list of pixels. And so it needs a image width and an image height. But this is a function that takes in an image. So let's just make it the same as the original that got passed in. So I'll do image width image and image height image. So that way the function takes in the image and uses that width and height for the parameters to reconstruct the image. So now let's see what we've got. Oops, I need one more parentheses to end the color list. Hopefully I should get the image with at least a good amount of the green removed. Awesome. So there's the green removed there. I know it's a small image. We'll make it bigger in a moment. But I've removed the green. And I know it's not perfect because this is just a simple threshold that I created. So now that that's transparent, we actually want to overlay this on top of something. So let me try a quick overlay and onto a square. This is 100 by 100 solid pink, right? Because 400 divided by 4 is 100. Whoops, square doesn't use two parameters. It only uses one. Sorry, I was thinking rectangle. Square 100 solid pink. There we go. So that's overlaid on top of another image. Let's go ahead and make it bigger. And let's make this 200. Cool, it's not too slow. Awesome. So I've actually removed the green and replaced it with pink here. But let's do something more interesting. Let's grab an image. I found just a pizza image on Shutterstock. Oh, actually, let me go ahead and swap my picture to the right. There we go. Let me go ahead and add the base image in here, just so we can see the befores and the after, and the pizza image. And I'll leave it pink right now just so we can see. I can hit run. So now we have the base image and the pizza image, and then this one overlaid on top of pink. Now instead of pink, let's overlay it with the pizza. So let's get rid of the solid pink square here, and let's just write pizza image and run that. There we go. So we have our base, our pizza, and then we have our pizza queen meme. All right, so that's going to be the end of this coding activity. This is all the code right here. I'll also share a link to this sample code, the completed code. I'll share the link in the description. If you want to check it out, modify it, try out some other images. Now, this threshold is specifically for this amount of green. If you have different levels of green, you might have to adjust the threshold as well. So that's going to be it for this video. If you are watching on Udemy, there will be some assignments for you below. And for everyone else, thanks for tuning in. I hope you enjoyed this video, and see you on the next one.